Hello and welcome. We're going to go through details on notes that have to do with intro to area and perimeter. It's really just intro to area at this point, but area and perimeter are often talked about kind of as a partnership. So first, let's look at a handful of area formulas and calculations, how we can make sense of the formulas, and how that can also help us make sense of the calculations. All right, so for a rectangle, we are going to have base times height is our formula. We have a drawing here that if you click on edit, you can add things, you can zoom it in, all that kind of stuff. Similarly, I have a second drawing here, but this one I'm going to do dissections with. But the thing about a rectangle is it's already in a shape that is easily calculated, easily visualized in terms of I have 4 rows, 6 columns, and that builds this group of 4 by 6. And then for my calculation, what I'm going to be doing is using math.new with all my calculations. And all I'm doing here is just kind of showing 4 times 6, and then see what that equals, and that's going to be 24. We're just showing a lot of expressions throughout this set of notes. Let's see if I capture that again, make sure it's going to my clipboard. It is. Perfect. Paste that in, resize it so it doesn't take up extra space. All right, parallelogram. Before I get to the formula, let's actually get into the dissection. We have some applets where you can play around with this, but I'm just going to do a simple dissection where I trace over certain parts with the polyline tool and then see what I can do to move those pieces. So I'm going to kind of slice it up and move pieces around. So the way I'm going to slice it is this triangle that's over on the left side. I'm going to cut that off. And then I can move it over here. And essentially what's happening, actually let's duplicate it. So that's like copy and paste and move it over there. So I see that those two pieces are the same. This one I'll make transparent. And I'll make it quite thick so you can see where it came from and now where it went. So like that piece that's chopped off is now over here. That gives me a box that's 4 by 6 because I chopped it off and now it's over on the other side. So again, I have that same calculation as before, 4 by 6. It's going to go right there. And the formula for a parallelogram means that if I can always chop off one side and move it over to the other, or it really doesn't matter what my tilt or shear, the slant in it is, then I can just use the same calculation as a rectangle. It's a base times height. All right, now let's look at a triangle. There are more than one way to look at this. I'm going to show you one where we can dissect it to make the most sense of the formula. I'll make this a little bit bigger too so we can see it on the screen. So I'm going to do a couple of things. First, I'm going to look at trying to cut it across this line right there. And I'm also going to cut it across this line here. So I'm going to use those two lines and I'll make them thicker. There we go. So that's like my cutting lines. Again, I'll use my polyline tool to dissect these pieces. So if I take that piece and then I'm going to take my other piece as well on this side. There we go. So I take those two pieces and I can do a couple things. One, I can rotate them. So I'm going to rotate it 180 degrees and then move it down here. I'm going to do the same thing with this one. I'm going to rotate it 180 degrees and move it down there. And so what I notice is that I took these two top pieces off as if they're gone now. And they're reshaped down into the bottom. So if I were to move those back, I'm going to make each of these, I'll first I'll copy and paste them. And then I'll move them, and I'll change the other colors so that we can kind of almost black out that top part and just be left with the part on the bottom. So there we go. Rotate this around. And these I'll now make, let's say, gray. So that gray part's gone, and it's now just the blue shape on the bottom, which is a rectangle. But notice this rectangle has a height of 2, and the base is 6. So the height is cut in half, but the base is still the same. So it's like I take the whole box 4 by 6, but I only want half of it. So that formula is going to be my base times my height, 4 times 6, but then cut in half. And if I were to show that as a calculation, I would just do 4 times 6. Let's put that in parentheses and divide it by 2. Oh, let's try that again. 4 times 6 divided by 2. So we're going to have 24 divided by 2 gives us 12. So a very similar calculation, except this time it was multiplied by half. Again, we don't need it that large. Bring it back down. All right, let's look at a kite. So I have my original, and I'm going to have my dissected version. This one actually already has some dividing lines for me. If you kind of see these 2 lines going across, those are diagonals. That's what we call those, because they cut across a shape. We call them diagonal. And I'm going to use my polyline tool again, and we're going to fill in a space down here using these triangles up above. So how do I do that? I'm going to use polyline and 3 clicks and return to my original position. I'll do the same thing for the triangle here on the other side. Now I'm going to select both of these and copy and paste them. Whenever you copy and paste something, if you do 2 arrow taps up and 2 arrow taps left, it puts them right back on top of each other. That's just a helpful thing to know with Google Apps. Again, I'm going to try and fit this one down here. Now, if I bring it down here, you notice I can't rotate it into place. It doesn't really fit there as a rotation. But what I could do is I could reflect it. So I dragged it down, and I'm going to flip it horizontally. That's a reflection. And then I'll do the same thing with this one. I'll drag it down, and I'll right-click, and I'll go to the rotate menu, but I'm actually doing a reflection. I'm going to flip it horizontally. And then I'll highlight these 2, make them gray, just to kind of color them out. And notice again, I have that same kind of box as I did before, where it's not the whole 4 by 6 box, it's just half of it. So I'm going to have the same kind of calculation that I did for the triangle. So kites and triangles, very similar in the way that they fill the space of an area. That means then that my formula, I could say, is base times height divided by 2. More commonly, though, because we refer to these lines that are cutting across a kite as diagonals, you'll see it written as diagonal 1 times diagonal 2 divided by 2. But to me, it's the same as a base times height divided by 2. All right, let's look at a trapezoid. I'm going to click on the drawing and then edit it. Let's make it a little bit larger, easier to read on your screen. This one has a couple of dissections. So the first thing is I am going to wind up cutting it in half across here. Okay. Now there's more than one way to do this. I'm going to do it with just a single shape the first time. But there is a way that you can split it up into 2 shapes and fill a box perfectly. What we're going to do is make it look like a parallelogram. So if I were to take this top piece and trace it out where it splits the top half and the bottom half, then what I can do is I can rotate this 180 degrees, and it fits nice and neat right there. And actually, I'm going to do the copy paste so that I have two versions of it, and the one I leave behind I will color gray, showing that I've left it behind. So now I have this shape down here. This shape on the bottom is a parallelogram because this incline there gets matched again here. Now, my drawing's not perfect, but it's close enough that we can still make the argument that's a parallelogram. And this parallelogram now has a few measures. It's got 3, and then it has 5 more. So it's not 6 wide anymore. It's 3 and 5 put together. But the height is still 4 divided by 2. Pardon me, the height is still half the height. In other words, it's not 4, it's down to 2. All right, so to get that, how would I set that up as a calculation? Well, let's go in here real quick, and we'll put these side by side so we can kind of see them. Perfect. And we'll just do a new one. So I'm going to insert a new math expression, and I see that I have the base. It's going to be my base times my height divided by 2. But my base is really 2 numbers put together. I have 5 plus 3. And the height was 4, but again, it's a half height, so it's like that half box. So now I have this kind of calculation. It's 5 plus 3 or 3 plus 5 for that bottom. And as I simplify these things, 8 times 4, 32 over 2, and that's going to give me 16. So let's take a picture of that. Put it here. Perfect. Let's get back up to where we were. So then what does that mean the formula is? This formula is probably the most complex to remember, but it's the pieces of the 2 bases, so that's the 3 and the 5, added together, and then the height, and then we're going to divide everything by 2. And so now let's continue with our second section here where we're solving for missing pieces. We're going to be repeating a lot of these problems. Some of them it will be easier to just go into the formula and do some equation solving. Some of them it will make sense to kind of think about the redrawing of the shape in order to help simplify the formula. So let's start out with this first one. We have a rectangle. As a reminder, the formula for the area is base times height. And to calculate the area here, I see that I have an area of 10 and 10, or sides of 10 and 10. Don't know what the short sides are, but the area is 50. So what I want to do, and I'll refresh this, reload it. I'm going to say that I have area equals base times height. So there we go, we have A equals BH. But what I want to do is replace the pieces that I know. So I have the area is 50, and my base I don't know, but H, the height is 10, so B times 10. Now I can say let's divide both sides by 10. So I click on the equal sign, divide both sides by 10, and now I have 10 over 10, that's going to become just B. And on the other side I have 50 over 10, and that will equal 5. So my piece then that's missing, the question mark, would be 5. So I can screenshot this. And let's say it's going to the clipboard. Cool. Capture that. Paste it in. 5 equals B. Shrink it back down for size sake. Now let's look at the next one. On this next one we have a parallelogram, which again is base times height. I'm going to do some redrawing just to help understand the picture a little bit better. I'll make this bigger for myself. I will also do the polyline tool like we did before. I see a 5.8 and a 7.9 here. And if I try to cut off this triangle on that side, and then I can move it over here, it would fill in that space. What does that do for me? That gives me a shape that looks like this, where the height is 5.8 and the base is still the same as this question mark, but it's just kind of slid over. So now I have 5.8, the area is 46.4. So again, I'm going to be using this same calculation, but instead of the area being 50, now it's 46.4, and the height is 5.8. There we go. And I will, again, click on the equal sign so I can do something to both sides. I see it's 5.8 times b, so I'm going to divide by 5.8. And that allows me to put those two 5.8s into each other to make a 1. And I can divide this side, and it equals 8. So the height is 8. Let's screenshot this, put it into my clipboard, and I'll add that to my work here, resize it, keep it in the box. Excellent. For a triangle, this is where we have the base times height divided by 2. Oops. There we go. Base times height divided by 2. I'm going to do some redrawing to help understand a little bit of how this shape fits into a box. So the box that would work here, based on the pieces that I have, so I'll change to a polyline, is going to be this distance here, and then we're going to not go 6 feet tall, but half of it at 3. So that would be a box that is equal to the other piece. And we have a horizontal measure of we don't know how much, and we have a vertical measure of 3. So I'm going to put some of these pieces of information on here. So this is 3. I'll make that bigger, easier to read. And copy paste it. We'll put a question mark down here. We don't know how much this is, but the area itself is equal to 30. So now if I think about this box, I can do this a couple of different ways. So I can do it this way, where I have like the base times the height equals the area, and the area in this case is 30 equals the base times 3. And if I want to get that base by itself, I divide both sides by 3. That gives me just b. It makes b times 1 on that side and 10 on the other side. But there's another way I can do it, so I'm going to show that as well. If I were to start with the area equals base times height divided by 2, which is like our triangle, we can put in the pieces into this one. So let's substitute in some pieces. So the area is 30, and the height that was written in there was 6 was 6. And now I can simplify it, same idea, it's b times 3, so I'm going to divide by 3. I still get the same process from here, and it comes out to be 10 equals b. Now, how did I know which one was the base and which one was the height? Here's kind of like the key pieces. So I'm going to move these a little bit out of the way here. Notice that I have this question mark, and then I want to know, do I use the 6 or the 7.5? The way you know which pieces to use is you look for the perpendicular relationship between them. That perpendicular relationship tells you those represent the two measurements that are used to calculate the area. So we're going to screenshot this work over here, copy and paste it in. All right, let's wrap up with a few more examples here, a couple of these. It might be helpful as we try to redraw them. So again, we are given the area, and we have some of the dimensions, but not all of the dimensions. And we're trying to solve for the missing pieces. Let's take a look at this one here. This is a kite. Now, when I look at this kite, I notice that it kind of has this folding symmetry here. I also notice that I can cut some pieces off and turn it into a box. So let's figure out what we can do with that. So for example, this triangle in the top left can come over into this piece up there. So if I take it and then I flip it vertically, it fits right in there perfectly. I'm going to be doing the same thing with this other triangle down here. So I'll take this triangle, trace that one out. Again, I'm going to move it over and flip it vertically. Rotate, flip vertically. You do not have to redraw it, but this helps a little bit in trying to make sense of it. So now, for example, if I were to look at this rectangle of the whole piece, I would notice that this rectangle is 6 inches in one dimension, but it's only half in the other dimension. And it says that the area of all those pieces is 23.4. So when I think about that, I would say, all right, 6 times something, so let's say 6 times x, is going to be the area, which is 23.4. Now, if I'm doing this, what I'm basically saying is that this right here is x. Let's make that a little bit bigger. Copy and paste the text box, and I'll say this side is 6. And the total for the whole shape, 6x equals 23.4. That's kind of the pieces that are being put together here. So then if I divide the 6 on both sides, I learn that x is 3.9. So in other words, if I get over to this text box and copy and paste it, I can say that this edge right here, x, is equal to 3.9. All right, now that's not what the question mark is. It's asking for the full distance across, not just half this distance. So if I were to add another calculation in here, and I'll say 2 times 3.9, and then just simplify that calculation. So 2 times 3.9 is, put this under here, is 7.8. Now there is another way to do it, and it's starting out with the area formula and then working our way backwards. So I'm going to show that calculation here too. This one is probably more popular the way that I'm about to show you, but I wanted to have some visual sense making of it for others as well. So the formula for the area of a, what are we talking about here? Kite. So the area of a kite is equal to the diagonals d1, d2 over 2. That is the area of a kite. Now if I were to kind of fill in those pieces, what would that look like? That would be the area of the kite is 23.4, so 23.4 equals the two diagonals, which are these on a kite. Those are the lines that cut across. So one of those lines is 6 inches, and the other one is a question mark. 6 times a question mark. Oh, it does not like the question mark, so we'll call that y. Move this up here. Oh, but I forgot something, if you notice. I need to fix a mistake. It's not just 6y, it's 6y divided by 2. Okay, so 6y divided by 2. Now I'm going to see what happens when I do some operations here. So 6 over 2 becomes 3, and then I can divide both sides by 3 to get that value by itself, and that tells me that 7.8 is my diagonal. The same thing, so whether I do it by solving just the formula, plugging the pieces in, or doing this, I still get the same answer. There are also calculators that do this with direct plug-in. If you just do a web search for area of kite and solving, it'll help you solve for a missing piece. And we're fine using those tools. You would just need to make sure that you screenshot how you use that calculator. In fact, let's try one of those calculators right here for the trapezoid that we're about to look at. So I'm going to make this larger just so I can see the pieces. And I'm going to do a web search here, just as a model. If I look up area of a trapezoid, it puts in a calculator here. Now, the difference is this one is solving for the area, but I already have the area. The area is 51.6. What I can do, though, is I can change where it says solve for area, and I change that to something else. The question mark in my picture matches the height, h, over here. So I'm going to say that I want to find the height because I don't know what that is. Now it's going to ask me to plug my values in. It says plug in my A base, or the top base. Well, that's 5.9. And notice that when you click in a box, it will often tell you where that piece is. So I'm going to take that out. When I click in this box for the A base, it will often highlight what it is. So that one is saying it's up there. Now it's saying you're talking about the B down here. That's 11.9. And then the area is the total space that's enclosed, and that's 51.6. And after I do all those things, it actually already has the calculation running for me, and it has it evaluated and solved and everything. And then I have this piece here. It says 5.79775. So I'm going to screenshot this and put that in for my work. And there we go. Now let's look at these last three pieces here. These three shapes, these are kind of irregular shapes, and that's the spirit of this last leg of what we're looking at. What I see when I look at each of these is I see a shape. It's a triangle, but it's hard for me to determine like what's the base and height, the two pieces that are like perpendicular to each other. But also what I notice is that I have 1, 2, 3 triangles around the outside, and that this has kind of a rectangular box enclosing everything. So the first thing is I notice that the box is 5 by 7. So I'm going to do a calculation for that to figure out what the area of the box is. 5 times 7. So the area of the box equals 5 times 7, which is 35. And then I can figure out each of these other triangles. So I have a triangle here, which is 1 by 1, 2, 3, 4, 5, 6, 7. So I'll say area of triangle 1 is going to be equal to 1 times 7, but all of that divided by 2. So there's one of my triangles. And then I have another triangle here that's 4 by 3. And so I'm going to find the area of that triangle. So area of triangle 2. And the way that I'm making my things do a subscript here, where it goes down like as a label, is you hold down Shift and click the dash button, which makes an underscore. An underscore in typing, especially with math, will do a subscript where it goes lower for labeling. Okay, this other one we said was 4 by 3, and it's a triangle, so we also divide by 2. So I'm going to do 4 times 3, but also divided by 2. And I'll put that one here. And then the third and final triangle is, we have this one where it's 4 by 5. So I'm going to say math expression, area of triangle 3 is going to be equal to 4 times 5 divided by 2. All right, so we have a lot of just kind of calculations going on here. And 7 over 2, I'm going to double click to get like a decimal approximation. And then we have this one is going to equal 6, and this one will equal 10. So we have a lot of things going on there. We have a 10, a 6, and a 3.5. Let's put some labels on there. So this is 3.5 up in this corner for that area. And then when I duplicate it over on this side, it's going to be 6. This area was 6. And then for this last one down here, the area was 10. And then how do I calculate kind of the differences or the blue area? Well, I take the total, which is 5 by 7, that's 35. And then I subtract those three numbers. So I'm going to do that as my kind of final calculation. Let's move some of these around. So we have triangle 1, triangle 2, and triangle 3. But then the total area, the area total is equal to 35 minus 3.5 minus 10 and minus 6. So we're cutting off, we're subtracting each of those numbers. And now it's just a matter of putting stuff together. There we go. And the area total is going to wind up being 15.5. So that blue area in the middle here is 15.5. And I'll make that quite a bit bigger. There we go. So the area in the middle is 15.5. All right, so I have that picture kind of marked up, but I'm going to take a picture of all these calculations and drop that in to the work area. And in fact, just now as I'm kind of going through this, I'm going to delete one of these pictures and have you guys just do 2 for your notes, because that's quite a bit of work just to go through each of those, and a lot of work to show. All right, that's it for the notes. Thank you for watching.